Okay. Ready? I just pan up to your portfolio. Anybody got problems? You know how to share the portfolio and then send a link?
Yep. Did you get mine?
When did you send it?
I sent it Sunday.
I didn't respond.
I didn't check.
See if you got a grade. There was a veteran student for the portfolio. You have to share the portfolio, and then you have to send the link to me or Dr. Norvell if you want us to be able to see it. So it's a two-step process. Plus Panopto has to be embedded in it, and it has to be managed so that it's open and available for us to share. I think it's the actual command. Now, is everyone logged onto the cloud as we speak? If you're not logged onto the cloud, may I urge you to begin to do so right now. March 4 is our last event, and if tonight was any indication, I think it is, about how well it's likely to go and how good it's likely to be, and how important the message will be. I think tonight shows us the way, so I hope you can make plans to join us on May 6th in Bay Point, 9 a.m. to 2 p.m. We start at approximately 9:15, but we end promptly at 2. So I can assure you of that. All right, writing assignment number 1. Does everyone have a grade?
Yes.
That's Mr. Jones has a grade. What about you, Ms. Wallace?
No,
Did you submit it?
no, not yet.
That would explain that.
Yeah.
Do you have a grade?
I have, but I'm not satisfied.
I didn't ask you that. That's two different answers to two different questions. I asked you if you had a grade. The
Yes,
answer is yes.
I think so.
Okay. So if you're not satisfied, what do you plan to do with it?
I'm going to submit for my writing form, right? Writing assignment.
Which one?
The first one? Assignment.
Move on, Ms. Lowe. It's March.
But the due date for the first one is March 18th, right?
Okay, then you can take another shot.
Thanks.
That's in 2 weeks.
I'm actually done with writing.
All right. You know, if you turn it in, it's good, then you can take the grade and move on. Is it good? Or you weren't satisfied? Ms. Schwartz, writing assignment number 1, you have a grade?
I think I do.
You think you do
I
too?
think I do, yeah.
You think it's something you're satisfied with?
Yes, yes.
Then definitely move on.
Okay.
All right, Mr. Aiello,
I haven't
writing assignment
submitted it
number
yet.
1?
I haven't submitted it yet.
No, Mr. Moniz,
I submitted the first draft.
Yeah.
Right back.
and you're going to change it and fix it and move on?
Yes.
Okay, Mr. Young?
I have a grade. I'm still considering whether or not I want to resubmit it.
Okay, well, you got a little time, but remember, if you can pick up some speed now, it wouldn't be a bad idea. Okay, so writing assignment number 2 is upcoming, and that has to do with hypotheses. Now, I don't want to go all scientific on you, and I think we had some discussion like that on before. We're not searching for new knowledge. We're searching to find out if a program or a production process works. That's our context. Now, the hypothesis is that the program, whatever it is, makes whatever it is it's supposed to make. Same with the production process. If the production process, then there's supposed to be a product. So beyond the abstract confirmation or concepts that we're using there, we're posing that we understand, particularly in the public sector, services in the private sector, you can't see the process working. You pick up hints of it, that is true, but you can't see a pattern of it working. In the same way you could see manufacturing processes work, like stamping out these plastic molded chairs. You could see it happening, and you could stop it if it weren't going well. Now, if Ms. Schwartz is at the teller's window, let's say, and she's in the midst of a problem with a customer, she can't simply pull the window down and walk away. So the question then becomes, is that a pattern? Is there a pattern there in the way that process was operating? That's what we're looking for. We're looking for patterns. And so our hypotheses are that the program works. Then we set out not to prove or disprove, but to find data that tells us something about that premise, whether we're in the right place or whether we need to make some changes. Mr. Young, you had a question?
I mean, I just feel as though I'm confusing myself, but the hypothesis is the same as the premise statement, correct, right?
You are not confusing yourself.
Okay, 'cause I mean, I was trying to come up with a different
I
hypothesis.
would,
and I said,
you
I
know, when we
think
do
it's
it,
the
no,
premise statement.
when we do 501, I have you start with the premise, right?
Yeah.
And I have you end with the premise in the capstone, don't I?
Yes, sir.
Okay. The only place in between that I change that terminology
It's not.
is in this course, because the textbook uses that terminology.
So then I already have all this.
That's right.
All right, I guess I'm just okay.
That is it. Yes, unless you do something strange, you got it. If a
X.
message video consisting of appropriate images, colors, appropriate voiceover, appropriate language, appropriate message content, then knowledge of the message content and intent to do whatever it is the message tells you to do.
Yep.
Same one you've been working on, right?
All right.
Okay, that's the hypothesis. Now, there are going to be a maximum of 3 intervening variables, are there not?
Yes, there
So
are.
every time you add an intervening variable, all you're doing is taking the existing premise or a hypothesis and adding that factor. If an informative video, whatever I said, with images and colors and voiceover and so forth and so on, then knowledge or recall and intent to act, right? If informative video, et cetera, considering gender of the viewer, comma, then recall of message content and intent to act. So the premise doesn't change, the original hypothesis doesn't change. It simply expands to take in another factor, one that could alter in some way the 2 components of the statement that we've made. Now, we may find, Mr. Young, as we gather data, what we thought was going to alter the relationship between X and Y, nothing happened. Okay, that's worth knowing. But we're looking in the data for patterns that either confirm or deny that. So we need enough data to be able to find patterns. And if we add 2 more intervening variables, thus 2 more hypotheses, what we're adding then is more variables.
So would you say we have a total of 4 hypotheses if we have 3 intervening
That is
variables?
correct. If you look at the outline, it's exactly what it shows you. So there's the base hypothesis and 3 hypotheses that take the base hypothesis and add a new variable.
Gotcha.
That's all you're doing. And I wanted to do it that way and keep it clean. So you understand that when you get to the intervening variables in your capstone in particular, you know that what you're looking for is a variable that may alter in some way the X and Y. And that you can't overburden your data set. Remember, you're looking for patterns. And every time you lose an observation through partial failure to get data back on an instrument, for example, then you lose a unit of analysis. It means a loss of an observation. You don't want to lose observations. We started on that very first evening, in February, with the whole point of observation. You're observing by measure. That's your lens. So you're looking for a pattern in the measurements results when you get them back. That's what we're going to be doing. Mr. Yost?
You said the intervening variable must alter X and Y?
No, I said
May or?
may. And then I went on to say that once we include an intervening variable, which may alter, which could be for good or could be for ill, we're guided there by the literature. Once we start gathering data and our data come back, and presuming the data are sound, it may show us that whatever that variable was did not alter the relationship between X and Y. I don't know what it's going to show. The point of the exercise is to learn that you go where the data take you. So you want those data to be strong enough to be clear. So you can find these patterns in X and Y and any intervening variables you put in there. And every time you add another intervening variable, you're adding more requirements of the data set. So if you start with a small number, which as we know is less than 100, and you have an X, a Y, and 3 independent variables, or intervening variable, that's 5 variables, and you're trying to make less than 100 observations work for you. More observations are always better. Right?
Let's say so.
Okay. Now, we're moving toward idea assignment number 2. Through hypotheses that we have concept names in, like production process or program, or GED, English education. We have to turn that into a variable. A variable is something that varies. When you drive your automobile, even with cruise control, don't you find the speed varies? Changes, doesn't it? Well, first of all, you have to have a scale that can allow that. There has to be a scale that can allow variation. And when you don't have variation, you have no way of finding a pattern in the observations. So here's where we draw on the literature. We're looking at sound scales that have been used in projects similar to ours, or close enough that we can take the scales and adapt them to our needs. Adaptation means changing a key word or so. It does not mean leaving an item out. That's not alteration, that's adulteration. So you can't adapt an instrument by saying, I don't like items 1 through 3, so I'm going to take them out. Because if you do that, you've invalidated the instrument. Can you change the wording of items 1, 2, and 3 without changing the intent of the original item? And the answer is yes. That's an adaptation. All right, so if we have variables then, variables are going to be measured with scales, and scales can take on various values along the scale. So once we get the scale back from our observations, and our observations are made of units of analysis. So did everyone see Ms. Nevins standing in the anteway to room 308 up there this evening? Did you give her any data? Have you already done it? She was trying to get more, right? She was making an observation. That instrument that she's using is the observation. So when she gets the data back, she will have an observation from each of you, which she will then input to SPSS for purposes of finding some sort of pattern. Is there one there? I don't know. We don't presume there's one there until we start having the data. We don't presume to start looking for a pattern until we have the minimum large number, which as we know is 100, correct? All right. Then we can turn our attention to measures that are descriptive. So, measures of central tendency, means, medians, modes, and I've added the midpoint. Now, Ms. Schwartz put in here that in the discussion that means, medians, and modes represent a coefficient. Or coefficient represents these concepts. What's a coefficient?
I think it's calculated by a
Thank you, Ms. Schwartz. Chinese, Ms. Schwartz.
Go, continue.
Apparently, Ms. Schwartz has handed out to you, Ms. Lowe.
Oh.
What's the coefficient?
I mean, it's a number that
Yes, it is. It's a number.
based on the mean. I think it's based on the mean and median. And
You might get a coefficient out of it, you're gonna get a number.
Yeah.
Generally speaking, a coefficient is going to go to some further analysis.
Yes.
But you will get numerical values that go with measures of central tendency. Now, measures of dispersion, that's the other side of central tendency. So with central tendency, how close are they together toward the middle? And with dispersion, how far apart away from the middle and each other are they? Okay? So that's where we have a range, which is simply a listing of all the values that appear in the data set using the scale that you apply for the observation. So when you ask the statistical program to give you a range, it's going to say, go into the data set and find the values that it came up with from the data you gave it. Now that may not encompass every value possible on the scale. But the values that are there in the range better be associated with that scale, or we've got a big problem. And we don't want a big problem. Now, I've added the midpoint to the measures of central tendency. Because in my view, you don't understand the middle until you understand the midpoint. Now, the midpoint is that value which is directly between the minimum and maximum values achievable on the scale, directly in the middle. The middle arithmetic value. Mr. Young.
So that means that one of our readings might not necessarily hit that point, but you just want us to identify what that point is.
Without knowing what that midpoint is, it's going to be meaningless to interpret the mean, median, and mode.
Okay.
Because the mean, median, and mode, look at this, are measures of central tendency. Okay, so if we were trying to figure out and interpret measures that we get back, if we don't know where the arithmetic middle of the scale is, it makes it more difficult to understand where these values that we're calling central tendency fall. Are we above the middle? Are we below the middle? All these measures do is tell us how close around a very common value that was found from the scale. That's all that does. So by knowing what the midpoint is, we're in a better interpreted position. Same with the measures of dispersion. So the range then is the list of all the scores found in the data set based on the scale that you used. Now, standard deviation is the average distance between the data points on the scale. How far apart they are, right?
Average distance between the what?
The average distances between
The data?
the values that appeared from the data set associated with the scale. Now, the mean, median, mode, range, and standard deviation all assume you have an actual scale. Number one, scale that's valid and reliable. Years, for example, is the valid and reliable scale we've chosen to accept by consensus, not because it has any magic, as the scale measuring time, right? And that's built around the amount of light that we were able to see. And the months that we created as 12 points along the year's calendar are all based on the amount of light, heat, etc., based on the rotation of the sun, but for the Earth. But the important point is we all accept that. There's no magic to it. In fact, it has a great deal of error, right? Last Saturday was the 28th of February, right? And yet, we have what's called a leap year, right, which adds an extra day, right? Okay, well, if you have to, oops, we missed one. Let's try to account for it. Okay, here's a placeholder, we'll throw it in there in February. Great, makes that last a month longer. I noticed that on WRNI, that twice a day you get the British BBC newscast, 9 a.m. and at 9 p.m. or 10 p.m. And when they announced the 10 p.m., they announced the Greenwich Mean Time. Now, Greenwich Mean Time was set up a long time ago. And most navigation today, and it was done for navigation purposes, but most navigation today is not done using Greenwich Mean Time. Is it? You got a GPS in your phone, right? It's not hooked to the Greenwich people in Greenwich, England, right? Is it? No, it's hooked to a satellite, right? And then there's the famed atomic clock, most accurate timepiece known to human time, which has to be periodically recalibrated. Despite how powerfully accurate it is, it has to be, sometimes they actually stop it so that the rest of the world can catch up and then they start it. It's not long, but there's that much inaccuracy in it. So all scales have error in them. So our purpose here is to find scales with as little error as we possibly can, so that when we make our observations, we can rely on the data coming back from those observations. The measured central tendency measures of dispersion are only for one variable. You with me?
For each of those?
Means, medians, and modes, standard deviation, and ranges are all for a single variable, not two. When we stated our premise, Mr. Young, the base one, we had two variables, didn't we? If high quality informative video, then recall and recognition of its content.
Call to action.
Okay, so we got two variables. Now, can we analyze them with means, medians, and modes, standard deviation, and ranges? And the answer is yes, one at a time. And if we do standard deviations, ranges, means, et cetera, do we, one at a time, do we know anything about whether those two variables are related?
Not at that time.
No, we do not, no, exactly, not at that point. But we're going to put these data through some analysis work to yield coefficients described by our own Schwartz to tell us if they relate. Now, when we do that, the assumption is that we've met the requirements for that kind of analysis. Number one, we have large numbers of observations. Number two, we have normally distributed data. And number three, all of that is based on having a scale which is valid and reliable. With me? So if X is normally distributed, but Y isn't, we got a bit of a difficulty trying to relate them, because they didn't behave normally. It's like going out on a date with a whacked out bipolar person when you're actually normal. Not comfortable, is it? That's what you want to avoid. You don't want to go with a bipolar whacked out person or variable. So we want these variables to be as closely to normal, as close to normal distribution as possible. Because that then means we can put them together and see if they relate. If they don't relate, it may be that we didn't collect enough observations to get a normal curve, and they could relate, but we just didn't go for it. Or it could be they don't relate, whether both are normally distributed or not. Well, we don't know that, do we? So what we want to do, because we get one shot in our capstone, is to get as close to normality as possible. And the way you handle that is by getting a large number. Did you have a question, Mr. Yost? Or was another?
Yes, I actually have a question, because when we do the SPSS, we put all the data into SPS,
That is
and
correct.
when it's calculating, it basically calculates the relationship between all three intervening variable and the X and Y.
It can do that, Ms. Lowe, but you're jumping ahead.
Oh.
Way ahead.
So we're going to separately plug in each intervening variable, the data for each of the intervening variables to SPSS, correct?
For PA 503, LEAD 503, yes.
Okay, all right.
All right? And then we have descriptions of the curve of the data. And is that curve or shape that we're trying to find out about? So in addition to having the central tendency and dispersion, we're interested in mathematically, are the data normally distributed? So we have a value that we can ask SPSS to create for us called kurtosis. We don't want the data to be peaked, and we don't want it to be flat. We want it to be bell-shaped, right? Kurtosis tells us how far mathematically we are from being bell-shaped. If the curve were bell-shaped, we would have a value of kurtosis of 0.
Say that again?
If the data were normally distributed in a bell shape, our kurtosis value would turn out to be 0. If it were bell-shaped, our skewness value would turn out to be 0. Skewness is whether it's sloped in one direction or another. Kurtosis is peaked. Skewness is slide one way or the other. Right? It's going to be a mathematical figure, so we'll be able to have a numerical value or coefficient, which will tell us how close or how far away from normality we are. And then we can ask for a histogram to give us a visual interpretation of the data. All three of those, plus the measures of central tendency and dispersion, will allow us to interpret what we see. Sound reasonable? Okay.
Dr. Paul?
Yes,
I'm
Mr.
sorry, I just can't see the last word down there. I can know it begins with I.
Well, that is
Histogram?
interpretation.
Oh, interpretation.
And by the way, the slide, the PowerPoint is in the resources for your review if you wish.
Okay, thanks.
It's listed under the M's as March 4. All right, so I created a dummy data set. This is very much like your assignment PA 503. That help? As you see at the bottom, there are two tabs. One is highlighted in gold or yellow if you prefer, because that's the one that we're looking at. We're looking at the variable view page. What we have here is a pre-test, post-test illustration in an educational setting. So Ms. Waleski, this may be close to where you're going to be. Okay? So the first thing we have to do in the dummy data exercise and later in your capstone is create the variable view page. So what I did was start the variable view page with a code number. So I gave every respondent a number so I could keep track of the data in its original form. So the way that would work is that Ms. Waleski and I might go to her English TED classroom on the first day of instruction, and we would hand out the pre-test and we would get the pretest back from an individual and assign a code number to it. Make sure that the individual knew his or her code number, or we kept a log whose name went with what code number, only for purposes of being able to do the post test. Right? So we need a code number because we need to be able to match a pretest score with a post-test score. And if you cannot match the same person's pre and post-test, you can't do any analysis.
So pre-test meaning what? Like, so when you say pre-test, I just want to make sure I understand that.
Pre-test means prior to the X being conducted or the program. So in case, let's say, I mentioned Ms. Walesky, she's working in GED education. So we were arranged to go to Ms. Walesky's place of GED education, and on the first day we'd walk in and say, hello everybody, we're here to do a pre-test. We're going to test you on what you know now about this subject. Okay? Sound reasonable? And then Ms. Walesky and I would do the procedure I just described. We'd create a code number so we could match the pretest with the post-test. And then we'd give the pretest to each of the participants in the GED program. Okay? We would collect those data, we would come back, and because we were wise, like Ms. Lowe, before she went to gather data, she had a variable view page set up, right, Ms. Lowe?
Yes.
Largely because I make you do that.
Yes.
That will make it easy when you're ready to go do data. So Ms. Walesky comes back with her pretest, and then because she's done this structure in the variable view page first, she's ready to enter data immediately. So if you look across the top over here, starting in this column, you see the pretest questions. Then, at the conclusion of the English instruction, course, whatever, Ms. Walesky would go back, using the same code numbers to the same person. Ms. Walesky would hand out a post-test, which is after the X. Post, after X. We would then collect those data, match the code numbers so that we were making sure we had the same person. And then, because Ms. Walesky was wise enough to have set up the variable view page ready to go, we set up right here, you see, to enter the post-test questions. Now, in SPSS, columns become variables, and the rows are units of analysis. So it is imperative that if we are doing a pretest post-test, that in order to match the results from the pretest, a person who's in row number 1, we have to be able to put the post-test in row number 1 also, for that same person. Did you follow, Mr. Moses? Now, the term pretest and post-test are commonly used in the literature and your textbook, etc. It doesn't necessarily have to be a test in the sense that I've created here, nor in the illustration that I've mentioned with Ms. Walesky. It simply is a measure of whatever it is that the Y is supposed to be before the X is administered, and then at the end of whenever the X is completed, the post-test of the Y again is the same test or scale to find out if there was a change in between.
So when Ms. Nevins is doing hers, is she doing a combination of both?
Who?
Her, Kelly Nevins?
No,
She's doing post?
she's doing what's called a cross-sectional one point in time observation. It's not illegitimate, it's not wrong, it simply leaves out some important comparisons. If she's also, and I don't remember, yeah I do, I'm speaking out of faulty memory. She has, I believe we here formed her comparison group. So she's got a one point in time program group somewhere that she's gotten data from, and then she's got us as a comparison. So I misspoke. Okay? So with that in mind, by the way, if you have groups like that, then it's probably wise to have a variable that distinguishes what those groups are. Mr. Young.
Is it possible for you at some point to show us how to calculate the median, the mode, and the?
As a matter of fact, Mr. Young, my plan was to do it this very evening.
Oh, okay, perfect.
But I thought this was illustrative of where you needed to start in order to get
there.
to where you ended up. Am I right?
Absolutely.
Okay. So the next thing I did was create a group. Now, a group means that that's one variable with two choices only. So such groups as male, female. Such answers as right and wrong, yes, no. Now, if you want to include variables like ethnicity, there's more than one ethnicity, is there not? So it can't be one variable with two choices, like I did here. See, in my variable, the two schools are Tolman and Shea High School. One gets a 1 and the other gets a 0. Why 1 and 0? Because you can perform math with 1 and 0. And always have an interval of 1 between 1 and 0. If I subtract 0 from 1, mathematically I get 0. I mean, pardon me, I get 1, don't I? That's the interval. As long as I've got even a dummy interval is what that's called, I can do a kind of necessary analysis to get to whether or not that variable affects X and Y. That's where I'm trying to go. Can I compute a mean, median, and mode on it? No. But I can do frequencies on it. I can tell you how many were in each group, which is important because I want the groups to be balanced. I can't have 75 in one and 90 in the other. All right, so then let's see, let's do the teacher effectiveness one first. All right, the X is teaching or instruction, right, Ms. Walensky?
Yeah.
All right, so what I've done is go to literature, and I found a teacher effectiveness scale. And what I have here is a hypothetical version of that, and it has 10 items, okay? And each item is responded to in Likert fashion from strongly disagree to strongly agree. That means then that the lower scores are less favorable and the higher scores are more favorable. So it makes the interpretation of the scale easier. Now what are these items? Well, I didn't hypothetically create them, but essentially things like my teacher always was on time. My teacher assured me, made assignments clear. My teacher was organized. Got the picture? Mm-hmm. Okay. So this is a Likert response category set for a hypothetical 10-item scale. Now, teacher effectiveness scales can range in size. I think the SEEQ, which may be the one that our own Ms. Walensky ends up using at some point, is for adults. And I think it has 25 items if memory serves. So, there's a copy and paste feature here also. So as soon as I put the first one in, I can do this, copy it, go to the next variable, that shares that response set and paste, speeds up the creation of the data. All right, the next thing I want to do is create a missing data value. I want to do that because I don't want SPSS to interpret incorrectly a blank space. So if I tell it, when I don't know what the response to the item was, I'm going to give you a 9. And 9 is the convention. It's just what we've accepted for some decades. If you look at your keypad on the traditional desktop computer, or the number pad rather, the 9 is far out of the range of your fingers that would do 1, 2, 3, 4, 5. So it's as much bad as for any other reason. All right? So now it asks for, do you want no missing value or you want a discrete? I want a discrete one, so that's why I chose it 9. So then I do OK or cancel in this case. Then the next one I'm concerned about is coming out here. Now I'm going to measure eventually my observations, and so I want to make every one of the items from this first one all the way to the end scales, and you'll see that that's exactly what appears here. With the exception of this one, which was created, but that's what it is. Everyone with me?
Can I ask a quick question?
Certainly.
So I just want to go back up to school. Now, school is one of your independent variables.
That is correct.
Now, is it possible for me to have an independent, I wanted to do 3 because we
All
have to do
intervening
3.
variables.
Intervening variable, I'm sorry. I wanted to do gender, and I wanted to do primary language, but like I didn't want to list the number of languages. I just wanted to be English or other. Could I do something like that and English be 0 and other just be 1 if the
I would do
primary,
the opposite, but yeah.
or something like that, so I can like group, like for instance, I
Now,
could
when you
say
do
country
that,
of
that's
origin.
fine. That gets you to be able to do this, right?
Yeah,
But if language you speak is that powerful a value, you might want to leave it in. But I'm not telling you to do that because I know what the literature says.
okay, I'll look into it.
Please do. Because you don't want to start collecting data you don't need to. But your workaround is the way you would get to what would be a multi-category variable.
Okay,
But you're also leaving out data because you're either English or something else.
something else we use.
And you don't know what the something else
Something
is.
else is, okay.
Now, if the literature guides you in that direction, you're in good shape.
All right.
Same would be for where are you from? You know, Massachusetts, Rhode Island, Cranston, Johnston. Okay, that's not one variable, that's multiple variables. You don't want to do it that way.
All right,
Or you could even try to collapse it. You're from the northeastern Rhode Island and northwestern. Okay, now you got 4 variables, which is okay. And each can be either you are from that region, 1, or you're not, 0, right?
Mhm.
But you got 4 variables. Now, if you're going to do 4 variables, add 4 variables, where there would have normally been only 1,
yeah,
now you've burned the data set.
okay.
How many of y'all got those electric sockets at home? Have those little extender things where you can put more in? You got them all plugged in, right? It's not really safe, is it? No. Okay, but it's dangerous and it can lead to problems, correct? Think of adding more variables like that socket situation. Creating more problems.
Okay.
Now, the solution to the socket problem is to create more outlets. Well, the same thing with data. The solution to adding those more variables is to get more observations. Right?
Yep.
Okay. Now, so this is a Likert response-based set of items. And then I'm doing a test, pre and post. It's not Likert response. So as you can see in the values section, I'm going to assess each variable, each item in the test, either correct, 1, or incorrect, 0. Right? Correct? You with me? And the same here, should they skip an answer, skip the question, foul the answer, choose two of the multiple choices for rather than simply one, then I will record a 9 and essentially lose that test value. If you lose an item, you've lost the whole observation. Now that's going to happen. And the solution is you can't fix it afterwards, so you need to think about it beforehand. More observations. Simple arithmetic. All right, any questions about the setup of the variable view page? Everybody with me? Okay, so here we go. We're going to go look at some data. So see all these 1s and 0s, and over here in the corner you see 4s and 3s. Where do those data come from?
From the observations.
Exactly. That's where I would have normally have gotten. Now, PA, LEAD 503, you have dummy data. So you're going to make them up, just like I did here. You with me? Mr. Young?
Well, I was gonna use my real data. I wasn't gonna make it
That's
up.
right, because you're at the capstone stage.
Yeah,
But for the other folks who are not,
just make it up.
I'm going to create dummy data. But you're at the stage where you can use actual data. All right, fair enough. Now, let's get the display. All right, now, the question was, how do I get an SPSS means, medians, and modes? Well, the first thing I do is I go to analyze, I go to descriptors, I go to frequencies, and over here I choose statistics. Here are my measures of central tendency choices. Here are my central, or my dispersions, and here are the skewness and kurtosis choices. All I do is click on those. Note that I'm not clicking on anything just yet. Now, I also mentioned visual displays of data. So I would go to charts, I would choose histograms, I would say, show me the normal curve over it, I want to see how close visually it looks. I know I got the skewness and kurtosis, but I want to see how far off it looks for the regular human eye. Okay? Mr. Young, how do I do this? I want means, medians, and modes.
Analyze.
I go here, descriptives,
Just do-
frequencies, choose statistics on the right. Check out all those boxes here, the ones here, those here, and say continue. And I would pull my charts up, histogram, normal curve. All right, now I presume, Mr. Young, your question actually goes to seeing the one.
Yeah,
That'd be correct.
yes.
Okay. Okay. So, in all three of these cases, the teacher effectiveness scale, the pretest and the post-test, all I have is individual items. That's all I'm showing here, correct? It's not the individual items I want. It's their collective value. And for a Likert type response set, we create what's called summated ratings. So Mr. Young and the rest of us, we go to transform. Because what we want to do is transform the individual items into a single value. So that means we need to compute a variable. Okay? So when I can hit the compute variable button, the cursor defaults to this open window right here, over which is the title target variable. And what that means is SPSS knows you want to compute a variable from existing ones. So it's asking, what do you want to call it? So, you know, you can call it whatever you want, Uncle Gene, Blue Jeans, whatever. I tend to stick with my data set. And I usually would call it something like some some teacher, SUM type of sentence. Okay, so what this tells me is I'm going to add the items that form the teacher effectiveness scale. You with me? Because it's a summated rating. Okay, so what I would do is go to the first teacher effectiveness item. And as soon as I highlight it, note that the arrow between the boxes has lighted up and is now facing to the right. So what it's saying is, put it in there. Whatever I'm highlighting here, I'm going to put it in there. So, I've got it highlighted. Like I said, put it in there. Then it's a summated rating, right? So that means I add. I'm going to add each item to all the other items. Follow me, Ms. Malinsky?
Mhm.
Making sense to you? Say again?
So kinda.
Kinda, I'll tell you. All right. So if I've done this correctly, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I got all 10 of them in there, right? Now, why did I do this? Because I'm working with a perception scale based on Likert response categories. And the way you handle the scale is by taking the individual items and the observations therefrom and adding those individual items each to one another. Okay? Mr. Aiello? With me? Mr. Moniz?
Yes, sir.
You got it?
Mhm.
Make sense?
Yep.
Ms. Lowe?
Yep.
Okay, so this is very much like your patient satisfaction scale, I'm thinking.
Yes.
Okay, it's a Likert summated rating scale. I think your physician's satisfaction scale is also, I don't remember, I'm doing this from memory, but I think it's also a Likert response category set too, isn't it?
Yes.
Okay. Mr. Yost,
Yes, sir.
you with me?
Yes, sir.
Ms. Schwartz?
I am.
Okay, so the only thing we need to do is push the button, Max. Okay, now, see that little result there? Okay, when you get it from such a procedure, that means it's done, its history is ready to go. Okay? It's finished. So now I don't need that because I know it's over. Do I want to save this output? No, I don't. What I'm really interested in is the scale value. And there it is. Thank you. Oh, a mouse moved. All right, see what it does? It automatically creates it for you and puts it at the end of the data set. Okay? Now, we presumed it was a scale, right? We were told it was a scale. We took it from the literature, correct? And we got from the literature an alpha value. Did we not? But we wouldn't have chosen it if we didn't have an alpha value. So, we go to analyze. We go to scale. We go to reliability analysis. And what we want to know is, what's the alpha value for this set of items? So, what I have here in this window are the list of all the variables that are in variable view. So I want to select only those that are part of the teacher effectiveness scale. And I'm going to take these and highlight them, click on that arrow, and put them in that open box. Okay? So, here I go.
How did you get to the probability analysis?
What did you just ask me?
How did you get to the probability analysis? I just missed that part.
The probability analysis.
Is
You
that?
mean a reliability analysis?
Oh, okay,
I went to analyze,
okay.
got the drop-down menu.
Yep.
Saw scale. It's about 3/4 of the way down in the list. Clicked on scale, it gives me a drop-down menu to the right. And then I clicked on reliability. All right, so here we go, where am I? Okay, Mr. Moniz, you with me? By the way, this data set is in the sources. Play around with it. You with me, Ms. Valesky? Okay, pardon me?
Oh, no, I said I have it open, yeah.
Oh, good. What we're doing here.
Yeah, doing the same thing.
Good. All right, and note it says over here, what form or model of reliability do you want to do? And look what the very first default is. Our old friend, the alpha, right? So we don't want to mess with anything else. It's already there for us. So, here we go. Let's see. All right, now we have actual output.
8.59.
All right, so it says we got 35 valid cases. That's a large number?
No.
No. Total of 35 cases, so we don't have any missing data. Well, that's because I made it up so it wouldn't happen. What I didn't make up was that. That just happened. So that's just blind stumbling luck, made up out of the whole cloth, right? But if that were a real result, we'd be happy with that, would we not?
Yeah.
We'd be jumping
be
up and
happy.
down. Any questions about what I just did? Now we have an alpha from our own data to compare with the alpha we got from the literature. That's where you're in a position to answer Dr. Hall's question was, when you get to your data findings, and I asked you, when you show me the alpha, how does that compare with the literature? You will have the ready answer. In fact, you can anticipate you're going to get that question, put on your PowerPoint table that has alpha from literature, resulting alpha from data set. Okay, so we got a scale, we're happy, right? It's dummy data, so I'm going to say. All right, so let's go back to Mr. Noon's question, and we go, how do we run a mean, and do what happens when we get one? So we go back to frequency, right, Mr. Young? We scroll down all the way to the bottom of the data set. We put our important variable in there, the means, medians, and modes for one variable, right? Okay. And then we go to statistics, tell me the mean, tell me the median, give me the most frequently occurring case. Standard deviation, give me the range, give me the minimum value in the range, and the maximum value in the range. Right?
Yeah.
Found in the data set, not possible from the scale. And there's a big difference. Tell me what the skewness is and the kurtosis. Then I'll go to charts. Let me see a histogram with the normal curve imposed on it. I want to look at it, and then I'm ready to do, okay. It's working, Mr. Young. There it goes. All right. Let's look at the range first. Here are the range of values found in the data set, from 14 to 48. Now let's think about this. There were 10 items in the scale, correct? Each with the same response category set, strongly disagree to strongly agree, 1 to 5, right? So if I had 10 items and a person responded to 1, strongly disagree for each of the items, that would give me the minimum possible score on the scale, would it not?
Yeah.
Because you can't score below, I don't have a 0. I don't have a 0.5. The lowest possible value that anybody could have given me back was a 1, correct?
Yep.
Okay, so if I do my summated rating, the minimum possible score achievable is 10. All right, do I have 10 in the range?
No.
Okay, is that a bad thing?
No.
Well, since only 35 cases, no, not really, but ultimately, if you are doing observations with a significant enough number of observations, you'll get all of the values. So if 10 is the minimum value, follow that, Ms. Walensky, how we did that? How we got the 10?
Um,
I'm
I had
sorry?
something else that popped up on my screen, and yet,
I didn't actually compute it other than verbally.
oh, okay.
All right, do you know how I got the minimum value on the teacher effectiveness scale, hypothetical though it be?
No.
Okay, let's start over. If the potential answers go from 1 to 5,
Yeah, I got that.
then there could be a person who answers 1 to all 10, right?
Mm-hmm.
If a person answers 1 to all 10, that would represent the minimum possible score achievable on the scale, because there's nothing lower than 1 to choose, correct?
Right.
So if I multiply 1 times 10, I get,
Okay.
if I add 1 10 times, I get 10.
10.
All right,
So that'd be the
10 is
minimum.
the minimum value achievable
50
on
would
the
be the
score,
minimum.
on the scale. So I go to my range now, and I know that 10 is not there, which tells me if 10 was a potential value, and it was at the minimum, I shouldn't expect a large frequency, but I don't have it at all. Probably suggests that I don't have enough value or enough observation. Now, at the other end of the scale, it is possible for someone to answer 5 to all 10 items, correct, Ms. Walensky?
Yes.
So if I add 5 10 times, I get, what do I get, Ms. Walensky?
If you add 5 10 times,
Correct,
you get 50.
I do. So the maximum possible score is 50. Now you will note that the maximum possible score does not appear in the range from the data set, correct? So I immediately know I don't have enough observations, but then I only have 35 to start, correct? You would expect to see all values possible on the scale in the range if you have measured enough. Right? And if you've done that, the likelihood of getting the bell-shaped normal curve goes up substantially. All right? So remember the last item in the bullet list under the data that we were looking at on the PowerPoint? The last thing was interpretation. Okay, that's what we're doing. All right? Now, let's interpret a little bit more. Okay, we have a mean, we have a total N of 35, which as we know is not a large number. We have a mean of 36.31, a median of 39, and a mode of 39. Okay, well, it looks like the median and the mode are pretty close together, and the mean is 3 points less. Okay, that's good news, bad news? What does that mean? Well, remember in that list of measures of central tendency, what was at the end?
Midpoint.
Midpoint, all right. So on the scale, if the minimum is 10 and the maximum is 50, the difference between 10 and 50 is 40 scale values. Half of 40 is, if I add 20 to 10, I get
30.
If I subtract 20 from 50, I get
30.
What's the midpoint?
30.
30, all right, so the midpoint of the scale is 30, and look, the mean, median, mode, they're all above the midpoint. Well, if they're all above the midpoint, it's going to be hard to achieve a normal curve, isn't it?
Yeah, it's gonna be.
You wouldn't expect that. You'd expect it to be distributed normally around the midpoint, right? If you measured enough, that's what you would get. That's a rule of mathematics. That's not my rule, right, Ms. Walensky? That's just that people have done this for some centuries and come up with these rules that tell you how numbers behave. All right, Mr. Young.
So my only question is, what if you just have a great program and it works so well that everybody leaves learning something that, and your data shows that? Like, what's wrong with that?
Nothing.
Because I mean, this tells me that the teacher was
Wait,
really good, right?
hold on.
Oh.
First of all, you got me jumping in beyond the middle. to react to a question that has to do with data based on mean, medians, and modes.
But I'm just saying hypothetically, like, wouldn't that
Well, let's
tell
start
you
in the
that?
right place. Hypothetically, from hypothesis, your program is supposed to make X, the program X is supposed to make Y, right?
Right.
Okay. So let's say we're happy with the average score. I don't know that we are, because I don't know a number of things about the program, but let's just say that we're euphoric now. We look at, whoa, we're above the midpoint, yay, great program. Okay.
That's naturally what I would say. You
What?
know, I would naturally say that, like, oh my
I
God,
would
this
say,
is great.
cool your jets. How many do you have in there?
There's only 35.
How many times have you done the measurement?
35 times.
35 observations conducted once, right?
Yes.
I didn't say you didn't find anything. I didn't say it wasn't worthy to be happy, right? I just said that you got a small number of observations. Does this mean we should pull out the red and white bunting and celebrate? No, it means we might be mildly happy and have a ginger ale. But remember, hold on. This is but part of the picture, right? This is one variable. This is the X variable. What about the Y?
Yeah, we haven't even looked at that yet.
Right? So what this the substantive interpretation, not the mathematical, statistical one, might be, well, it looks like everybody responded to the 35 that they like the teacher. Because if the midpoint is 30, look, everybody's above that. They must have liked the teacher. Okay, well, maybe they did. Maybe, on the other hand, Ms. Valesky just got the first group that were happy. Now, I'm going to tell you what. Groups vary, don't they, Ms. Valesky, in how they become cohesive or not? Who's the strongest and who's not so strong in the learning? That changes the dynamic in the classroom. All kinds of things can go on. You guys are good. We got good students in this program. We do. You know what? I used to have a larger number of them. What happened? Did I do something differently? I'm doing the same thing I've been doing for 37 years. I got a little better technology to do with you guys now, if you call it being good. But we got the cloud, we got SPSS, and look, it's up and running and nothing's crashed. You know? You can hit these things. So would you want to make one observation and go, let's go to the board and tell us what everybody raised? No, I wouldn't. And besides, I'd be a smart person on the board that goes, whoa, we only have 35. This is the first time they've ever done it. Good news so far. One variable, though. I need to know more, right? Okay. You with me?
Mm-hmm.
Okay. So, what's the kurtosis?
481.
0.481. Well, not zero, but
You want
It
that
ain't
close?
one
You want that closer to zero?
I want that to be zero, yes. I want it to be closer. What's the skewness? Ooh, it's up there.
Oh, that's like,
Skewness is, -1. I don't want that to happen. So we got that baby sloped over here.
So you want that
So
close to
that's-
zero as well?
Yes, sir.
Okay.
So you see, once again, Mr. Young,
Yeah.
I don't want that.
I know.
It's lopsided.
I
I
want
don't
to
want my
see the
data
curve.
lopsided. So let's go look. Whoops, there it is. It's lopsided. What I want is for these bars to be under here. I don't want peaks like that. I take one. There was only one. The rest of these are under there. By the way, that I told you about the scale that I adapted and got published. It looked similar to this, except all these bars here were over. These were closer. There were several here that were close. The rest of the end did not punch out over the curve line, but there was one peak. But the kurtosis was it was minimal. So, the first time I was using adaptive scale, and the adaptation that I took it from didn't have as strong an alpha as the one I ended up generating. And they didn't provide histogram, so I couldn't compare what they actually looked like. But again, Mr. Young, this is one variable, one time, a small number of cases, right? Okay? You wanted to know how to do it?
That helped me out like tremendously.
Well, that's what I wanted to do. All right, does it help everyone else?
Mm-hmm. I'm sure once I get my data from the literature, I will probably be looking towards you for help.
That's why I'm here, Mr.
Again,
Yost,
yeah.
there, that's why they're
Yeah,
paying
I know.
medium bucks. These data didn't come from the literature. What you're looking at here,
Dummy,
these
yeah.
numbers, I made those
Yep.
up. I set up my laptop in my kitchen one Saturday afternoon while I was cooking on the grill.
During football season?
Hell no.
But I have a question.
Baseball season, Sooners were on the internet radio, so I could listen, do that, and cook on the grill. 'Cause, you know-
My only question is, so on the ones that are missing data
Yes,
under the sum of the post test, I
yes,
see that there's some empty spaces
You do,
because
don't
you're
you?
missing, but yet, because that's the teacher sum, and they probably answered all the questions on the teacher part of the survey, but not on the actual test.
can that happen?
Yes.
Yes, it can. Yes, it can, and you see what happens when missing data appears to SPSS.
You don't get a
So
response.
you might have 35 observations here, but you don't here, do you?
Right. Mhm.
Okay, well, do I want that?
No.
I don't. All right, now,
I was just gonna
There's a lot-
say, would you still, you wouldn't discredit those people who didn't, or would you? I mean, they're still in there, right? You still have 35 total.
I wouldn't, exactly. I'm not gonna give up data. I'm gonna put it in there and let SPSS sort it out for me.
Okay.
But I already knew going in that the minimum large number was 100. I quit collecting data
Yeah.
at 35. And I've seen people do this in the capstone. This is what I'm trying to get you not to do. Because if you started with 35, and you see what happens when you have missing data, you don't actually have 35. Now you've got an unbalanced combination of X and Y. You don't want that. There should be pairs of observations. Pair of, for unit of analysis number 1, of X and Y. They're your pairs. See the pairs? I want everybody to have pairs that line up with X and Y. Questions? All right, so in our discussion on the forum of descriptive statistics, we have a whole bunch of new stuff we can put in, right? We also walk away this evening with not only being enriched by Commander Hensler, but also a better understanding of statistics and SPSS and the dummy data exercise you're going to perform for LEAD/PA 505, or 503. Mr. Aiello, is that a confirmation?
Yep.
Or just sleeping?
Both. I'm
Okay.
just kidding.
Okay. Mr. Moniz, you all right back there?
Yes, sir.
Ms. Valesky says she's okay. Ms. Schwartz? Ms. Lowe?
Yeah, I just some calculation problem. I would work on it later.
Calculate. SPSS don't make mistakes.
No, not a calculation problem, just my mental calculation problem.
Well, that's because you're tired. So here's what we're gonna do. I'm gonna stop. This has been recorded, so if you wanna go back and review it, you can do that. And you can also pull up the data set from the resources section of the course. And you can practice on it.
I
That
can,
data set right there, okay, which is not a bad idea. Now, next week is spring break.
sorry,
No, I'm looking forward to it too.
Winter break.
I just hope it's spring. I'm gonna be out in Chicago with Mr. Levante, and according to the forecast, it's like gonna be 28 or something. Supposed to be in the 40s here, isn't it? Lucky you. What is it, Mr. Money?
Chicago's always cold.
Isn't it? Leave it to Aspen to choose Chicago for the spring break. And then I'll be back over in Albany until next Thursday, and then I'll be out of town. Be back on the weekend. Our next meeting is,
25th.
okay, but the writing assignment number 1, if you want to take another shot, if you haven't done it yet, is March 18th, which is Wednesday of the week we're back. Yes.
Yes.
16th is Monday, 17th is Tuesday, Wednesday of the week that we're back, all right?
you will be online.
And then, and I'll be online, I'm taking my computer to Chicago with me. But then we make the stretch run to May. And May 6th is the last day of classes.
This semester is crazy. I don't understand.
I know, it's hard to believe. Okay, but bear all that in mind when you're doing your calculations.
Yes.
Good luck.
I have particular problem. I mean, I'm just playing around with the data I got. And I'm not sure my procedure is right. Maybe I'm wrong.
Well, we'll take a quick look at it. Let me close everything down.
Have a good night.
It's you.
See you. So it is pretty great.
Thank you.
So I did, this is just the statistics for the trust
Didn't open it
scale
up.
I have. The trust is one of my intervening variables. Should I do the statistical
Take care, man.
analysis for each of the scales?
Did you do what, I'm sorry?
Huh?
Should I do a
Yeah,
statistical
too now.
analysis like the median, mean, and
Yes.
mode for each scale, for X
Yes.
scale and for Y scale and
Yes.
for my intervening variable scale?
Yes.
Alright,
For any scales that you have, including years, age, anything else like that.
got it.
uh,
Now, if you do a mean, median, and mode on your,
Yes.
tell me the variable view, please.
You mean the variable view?
I mean the variable view page. Oh, yeah, I'm gonna do it. All right, so here are the quality items.
Yes.
All right, what you first have to do is summated rating.
Yes.
Okay, then you run
You're
your
gonna say with you.
But it's honestly that
This is also where you want to do your, this is the items you want to put into your reliability analysis.
Big time.
yes.
How about Brett Conley?
But I'm doing
Yeah,
that
well,
I
at
did.
the same time
Broke
because
his
when I
finger
do
out
the
second
frequency,
Yeah, that's not a good way to
the
start.
statistics,
I don't
think
they
he
have the
moves.
sum.
Shirley should be canned.
No.
He didn't make
So,
moves last year. He didn't
Which
make moves
summation
this
I'm doing?
Well, last year, did
That's
you
not the
want him to
sum.
make moves?
You want the sum that
They were
comes
the
out.
President Cup winner.
Oh,
No, I know.
okay.
This year, they should have done something.
Oh,
They should have got rid of it.
That would be the
Yeah.
They're not gonna win the cup.
Compute.
So
No,
if
they're
you
not.
just dump people and get talent.
Oh,
we can't play past the second period.
because
Oh, yeah.
first
It's proven
I
we-
sum the trust
Gotta get rid of it.
Honestly,
and
you cannot
I
play
need,
past
All right, then you need a variable
Get rid of
called
your
sum
third
of
line.
trust, and then you take
You
the
get
items
rid
that
of
form the
each.
trust, put them in there, put a plus sign between each.
got it. And
See
for my,
alcohol?
Can I,
yeah,
Take it easy.
for the X scale, I need to also do another sum for the X items I have. And here you'll be sum X,
that's
and I'll
right,
do sum
some
Y.
teacher or some doctor, whatever you call it.
That makes sense.
I'm glad. All right, Ms. Lowe, let's go, good.
Yes. I think I'm
On the
very productive tonight. Yep.